What is trapezoidal rule? Trapezoidal rule, one of the fundamental rules of integration which is used to define the basic definition of integration. It is widely used rule. Trapezoidal rule is named because it gives the area under the curve by dividing the curve into small trapezoids instead of rectangles. Generally, we find the area under the curve by dividing the area into smaller rectangles and then finding the sum of all the rectangles. But in the trapezoidal rule, the area under the curve is divided into trapezoid and then the sum is calculated. Trapezoidal rule is used to find the value of the definite integrals in numerical analysis. Trapezoidal rules, also called trapezoid rule and trapezium rule.
Okay, now I will present about theory, the trapezoidal rule. So the trapezoidal rule is applied to solve the definite integral of the form integrate a to b fx dx by approximating the region under the graph of the function fx as a trapezoid and calculating its area. So under the trapezoid rule, we evaluate the area under a curve is by dividing the total area into little trapezoid rather than rectangle. So numerical method approximates to definite integral, then simplifies this by using trapezoid under a curve. Sum the product of function value and the width of each interval. Imagine a function on a graph. The rule sums trapezoid areas formed by connecting point to the x-axis. Narrower trapezoid mean a closer approximation to the true integral. And lastly, offer a numerical approach to understanding complex function.
For the formula, as you can see in the slide, you will be given a graph like this, and then you divided the graph into small trapezium. So you have y0, y1, y until yn. So the formula gonna be integrate from 0 to n fx dx, integrate 0 to 1 fx dx, plus integrate 1 to 2 fx dx until n minus 1, integrate to n fx dx. Okay, when you simplifies it, it's gonna be h over 2 f0 plus f1 plus h over 2 f1 plus f2 until h over 2 fn minus 1 plus fn. So the general formula gonna be integration from a to b fx dx equivalent to 1 over 2 h y0 plus yn. At the back there's a plus at yn plus 2 multiplies by y plus y1 plus y2 until yn minus 1. So there's h where h equals to b minus a over n. That's the general formula and how you get the general formula.
Okay, this is example question of trapezoidal rule. Is given integration AB fx dx equivalent to integration 1 3 square root x the power of 2 plus 1 dx. So first we need to find hash. Its given formula for hash is b minus a over n. So the b we can get from the maximum integration, which is 3, minus a, which is we can get from the minimum integration, which is 1, and over n. So that n we can get from how many we divided the trapezium. So in this question, we divided it to 4. So the n is 4. And the hash equal to 0.5. So to solve this, we need to create a table. So this table, it has the value of x and y. For the x, we can get from the minimum integration at the hash. So our hash is 0.5, so we need to add until it's reach the maximum integration, which is 3. So we get 5y, which is y0, y1, y2, y3, and y4. So for the y, we need to put the formula from the previous slide, which is square root x the power of 2 minus 1. So we can get this value, which is 1.414, 1.803, 2.236, 2.693, 3.162. So for the solution, this is the general formula for trapezoidal rule, which is integration AB fx dx equivalent to hash over 2 multiplies y0 plus yn, which is y4, plus 2 multiplies y1 plus y2 plus y3. So we put the value we get from the table into this general formula, and then we can get 0.5 over 2 multiplies 1.414 plus 3.162 plus 2 multiply 1.803 plus 2.263 36 plus 2.693. So for the answer, it's equivalent to 4.51.
Okay, now we move to the last part, which is conclusions. The trapezoidal rule is a simple and intuitive method for approximating definite integral, making it easy to implement. It is useful when the function is not easily integrable or when the analytical methods are impractical. In conclusion, the trapezoidal rule is a valuable tool for approximating definite integral, offering a balance between simplicity and accuracy. While it may not be the most precise method in all situations, it is of use and versatility, making it a popular choice in various fields. The trapezoidal rule is useful when the integral is difficult or impossible to evaluate analytically. The trapezoidal rule can give an overestimate or an underestimate of the true value depending on the shape of the curve. That's all from our group. Thank